Hello, good afternoon. Welcome to the 2025 GESDA anticipatory briefings. These are sessions where we ask scientists to share their vision for their fields with a 5, 10, and 25 years horizons. My name is Laurent Haug. I'm going to be your host. And we're going to start with a deep dive into the world of sleep, aging, and longevity. I think we all could find some relevance in that topic. So scientific advances are rapidly deepening our understanding of sleep as a critical driver of healthy aging and extended lifespan. From breakthroughs in sleep science and neurobiology to emerging technologies that track and enhance rest, sleep is becoming a key lever for preventive health and longevity. This anticipatory briefing will explore how evolving knowledge of sleep will reshape public health, elderly care, and life extension strategy over the next 5, 10, and 25 years. Our speaker today is the director of the Future Health Technologies Center program, at ETH Zürich, and also at the ETH Center in Singapore. She's going to be presenting for 15 minutes. You guys know the format, 15 minutes presentation, then 15 minutes questions. Please raise your hand, write your questions down, and also people watching us online, there is a chat where you can send me your question. It's time now to welcome our speaker. Please give a round of applause to Nici Wenderoth.
Thank you very much, Laurent. Thank you for joining us. Let me start with an anecdote. When we are hiring PhD students, we typically ask them how they deal with difficult problems that might be frustrating at times. And we had one candidate, and he told us, look, I'm trying really hard, but if I hit a wall, typically I take a good night of sleep, and the next day, I'm a new warrior. And obviously, we need warriors in science, so we hired him on the spot. Now, I think we all had nights where we felt like new warriors the next day, and that is already indicating it's not only resting, there's an element of renewal. Now, why is that important? It's certainly for productivity, performance, feeling well, but there is also something bigger at stake, and that is our health. And one reason why that is important is that our societies are getting older. What I'm showing you here in orange is the global lifespan estimate. So a child born in 2022, somewhere around the world, boy or girl, is statistically predicted to become roughly 74 years old. And you see, when we look 30 years ahead to 2050, lifespan will increase roughly by 4.5 years. But you also see this bar in green, and that is not lifespan, that is health span. And health span is the time you spend in good life, functionally independent, and where you can participate in life and in society. And you see, health span is a little bit shorter than lifespan. And even though that will also increase over the next 30 years, the increase is only roughly 2.5 years. So what I'm showing you here is a gap between lifespan and health span. And from everything we know now, the predictions are saying this gap will be widening over the next years. And that's a problem, because when we are in aging societies, we want to compress this gap as much as we can. That is one of the missions that science should take on in an interdisciplinary way. So one idea is that we can change this gap by asking longevity science. You know, a lot of this gap is caused by chronic diseases. Chronic diseases are typically age-related. It's things like cancer, metabolic diseases like diabetes, cardiovascular diseases, neurodegeneration like dementia. And the idea is, rather than targeting each of these diseases on its own, we might target aging itself. And when we slow down aging, we might also just delay the time of getting some of these chronic diseases. Now, one important tool that we have only discovered during the last decades are so-called biological clocks. So when we talk about biological age, we are talking about little damage that is happening to our cells and to our organs. You can think about that as from birth to death, we will accumulate more and more of that damage, if you like, the wear and tear of our body. And with biological clocks, we can now measure how quickly we move along this trajectory. So unlike chronological age, which is going for all of us at the same rate, when we talk about biological age, some people might age very fast, accelerated biological aging. Others might age a little bit slower, decelerated age. Might also be, or with biological clocks, we can now measure how we respond to specific stresses in our body. So for example, you are catching a bad infection. That might mean, while you are still fighting it, your biological aging might be a little bit accelerated. But once you're recovering, it is slowing down, and you might even revert to where it was. So more importantly, with biological clocks, we might be able to understand how we influence the aging trajectory. So we know already now there are certain drugs, certain supplements, where we are very hopeful that they can slow down or maybe even reverse biological aging. There are other things like lifestyle factors. So it's something like diet, exercise, supportive environments. Now there's one other lifestyle factor that is only starting to get traction in the longevity field, and that is sleep. And I think nobody here would doubt that sleep is really important for health and also for aging in a healthy way. But what we are starting to understand is how we mechanistically can use sleep to change health span or health in general. So sleep is the body's natural state for regeneration and recovery. And you know, for decades, we have mainly focused how sleep influences the brain. And there particularly learning and memory and, you know, the modification of synapses that are driving these changes. But we know now that we have to look at that a little bit wider. So sleep is still important for brain functions, but not only for memory, also for emotional regulation, for pro-social behavior, and for something we call brain cleansing, so where we are flushing out toxic waste from the brain. Sleep is also important beyond the brain. So we know now it's important for cardiovascular health, for immune function and the gut microbiome, and for metabolism. And much of that is driven at the cellular or at the molecular level. So sleep is important to maintain cellular homeostasis, to drive DNA repair, or in general, to maintain the cellular structure. The important thing, we know that now because we have tools where we can manipulate sleep, where we can look at certain aspects of sleep, and then usually in a closed-loop fashion, so we are measuring it and then we are intervening with these specific aspects. And when we change them, we can now test experimentally, does that change something in cardiovascular health or brain health or cellular processes? And that has given rise to a vision. When sleep is no longer something that is just happening to us, but something we can design. We can now do something like sleep hacking, and that might give us a lever for changing regeneration and repair. And that's not only important for health, it might actually change how we think about human potential itself. It might also change how we think as a society about protecting sleep. And you know, there's an important difference to other lifestyle factors. So if you want to exercise, you exercise. If you want to eat a healthy diet, you eat a healthy diet. But if you want to sleep, you need an environment that is allowing you to sleep. So that means you need protective time, you need a safe and quiet space, and you also need freedom from digital intrusion, which is, of course, very prominent in our time. In other words, we are in need of sleep-friendly societies that don't perceive sleep as something that is negotiable, but something that is worth protecting. Now, sleep hacking might have great potential, but it really also comes at a risk. When we now have tools that allow us to compress sleep, to manipulate sleep, and maybe even enhance sleep beyond the normal range, the question is not only what we can do, the question is also what we should do. So sleep is an unconscious state. And now imagine that while I'm doing sleep hacking, I'm giving you some advertisement during your sleep, or I'm putting some other thoughts into your brain. This is something we would not want. So there are some invisible lines of privacy, autonomy, and control that we do not want to cross. And now is actually an important time because these technologies are up and coming. So the decision whether sleep augmentation will become a trusted tool for public health or something we don't want to touch is made now. And I think it's very important that science, ethics, and politics are talking about that and discussing these issues, because science is moving fast. So when we look 5 years ahead, we will have reached an era of digital technologies. So what you see here on the left, that is how we do sleep research at the moment. It's in the lab. So you're coming to us, we are slapping electrodes on your head, we are putting a pressure cuff on your finger, and in our lab we might force you to sleep with one eye open. So a sleep lab is a highly artificial environment where we only test a few people for relatively short time. Now that will change because we start to have sensors, wearables, that we can give to people and they can use it at home. And we can collect data with high quality, high resolution over long periods of time. And not only brain activity, we can also measure other states of the body or of the environment. Additionally, we have technologies where we do not only measure sleep, but where we also try to modulate sleep. Neurotechnologies that we can give to people and that we can bring to the homes of people. And that is important because now we can augment sleep when it matters. And what I'm showing you here is an example from a hospital. And I mean, we all agree that this is a place where regeneration and repair is critical. But you also know when you are in an intensive care unit that an ICU is the most sleep-unfriendly environment you can be in. Because you have constant light, you have constant noise, you have people walking in and out. Now we have the knowledge to change this practice. And just to give you one example, if children are born prematurely, there will be a neonatal ICU until they have developed enough to go home. By using a simple intervention which restores the light-dark cycle, something that is similar to our circadian rhythm, the time prematurely born babies spend in ICU can be reduced by 10 days. And 10 days is a lot, so that is real impact. Now that is something we can do immediately, but other technologies are on the way, something like smart lightning conditions. What actually when you are flying with Swiss or with other major airlines, so when you are on overnight flights, there are smart lightning conditions, but not in our hospitals. Additionally, we also have now other tools we can bring to hospitals to really restore quality sleep that would be geared towards restoration and repair. So the biggest frontier is to understand whether augmenting sleep really has an influence on the aging trajectory. And I'm showing you here one example. So currently there is a lot of work going on in the lab, very often with animal models, to understand basic processes of sleep. And I'm showing you one here that is brain cleansing, the washing, the showering of the brain, if you like. So while we are awake, our neurons are active and we are producing metabolic waste that can accumulate in form of toxic proteins, something like amyloid beta or tau. And when these proteins remain in the brain, they represent a risk for developing dementia or Alzheimer's disease. So what is happening during deep sleep, neurons in our brain will start to fire synchronized. So together, many nerve cells will start to fire, and then they are quiet again in a very slow rhythm. And this slow rhythm is helping fluid dynamics in the brain, which are literally flushing out metabolic waste and try to get rid of these proteins. Now we know now that when we age, this mechanism is impaired, but we also learn how to restore it again using either new pharmacology or new neurotechnology to stimulate the brain. Now, 10 years from now, we need strong theories like that to start clinical trials where we combine personalized sleep interventions together with biological clocks to understand whether augmenting sleep really does something to the aging trajectory. And that will give rise to another vision. 25 years from now, we might live in a world where sleep is engineered with precision for healthy longevity. We might be able to measure brain and body states and autonomously change physiology quasi in real time. As such, sleep augmentation might become routine via technologies that can go home. Some of it might come as mobile neurotechnology. It might even be an implanted device. Others might be new drugs, then rather than sedating, will facilitate natural sleep-promoting states. Additionally, we can also use sleep to better understand the body's own regeneration and repair processes. If you like, it's a blueprint to understand how our body is regenerating naturally, and that will allow us to design biomimetic compounds that can replicate these regenerative processes. And with that, we might be able to push it away from just having benefits during the night into the awake time. So last but not least, sleep might be recognized as a human right. And that is not so much in a strictly legal sense. That is more in the sense that in our societies we are aware that we want to protect sleep. Policy might want to think about more sleep-friendly environments by restructuring work, education, and also digital environments with the goal to protect sleep. So the outlook is that sleep is a superpower waiting to be unlocked. A lot of things we can do already now. I mean, we have a lot of knowledge. We can change our homes, we can change our hospitals to make them more sleep-friendly and hopefully more recovery-promoting. But there's also a bigger ambition. Sleep offers a window to mechanistically use this stage to change something with aging. It might serve as a diagnostic platform, it might be used for a new therapeutic pathway, or simply for better measuring and understanding regenerative processes of our body. By unlocking this window, we might really transform how we use sleep. And ideally, we will measure, we will understand, and finally we will learn how to use sleep to not only extend human life, but importantly, human health. Thank you.
Thank you very much, Nici. I can tell you in 4 years of hosting the anticipatory briefing, this is the most packed room we've ever had. So a lot of people interested in this. We're going to take some questions. Please stand by. I'm going to show the team, and they're going to bring you the microphone. We're going to start here, and then we're going to go second question here, please. Please introduce yourself
Out of personal interest, what is the value of a power nap at noon?
Sorry, I didn't hear your question.
Out of personal interest, what is the health value of a power nap at noon after lunch?
Do you recommend the power nap, and what is the best time for it, if we can go there after?
Yeah, so there science is a little bit divided. So some people would think don't do the power nap, but make sure you are sleeping well at night. And maybe I give you a more scientific answer to that. So generally, how well we sleep at night really depends on two things. So one is our circadian rhythm. So you know we are roughly in this 24-hour rhythm. Everybody who has traveled abroad and had a massive jet lag knows how difficult it is when you are not to sleep if you're not in your own time zones. That's one mechanism. The other process is something we call sleep pressure. So in order to be able to sleep at night, you have to build up this sleep pressure during the day. And a nap is not good for building up sleep pressure. Other things are, so for example, exercising, being socially active, being out and about. So these are things that can happen and should happen during the day to build up sleep pressure and then potentially sleep better during the night.
Thank you. We have another question. Please introduce yourself in one word and a very brief question. Thank you. Can you stand up so we can see you? Oh, sorry, there's somebody behind you with the microphone, and then you're going to get the microphone after.
No worries, I'll give it to you in a second. Just a quick question, Bernard, running a funding agency. Did you hack your own sleep? And if so, how? And just also, what's a good duration of sleep? Is there any good answer to that?
So there is not really a good answer to the duration of sleep because that is indeed very individual. So, and I'm very sorry for being unspecific with that, but sleep is really one of the things you have to personalize because there are really huge differences. How long we sleep and also whether we are, you know, the morning person or the evening person. So it's not a myth, that is true, right? So duration of sleep, not so easy to say. So right now I would say what is probably the best studied method for sleep hacking is a way to enhance deep sleep. And how that is done is typically we measure activity in the brain. Deep sleep is characterized, so we are measuring EEG, the electrical activity of the brain that we measure through the skull. And deep sleep is characterized by very slow but very large oscillations. And we are trying to enhance these oscillations. You see, I'm snipping my fingers, and the reason is we are measuring that online, and we are then playing tones that only the person who is sleeping can hear to boost the activity in the brain. And that is working surprisingly well to enhance deep sleep. And it has also been shown that this can have positive effects on health and on other things.
Thank you, Madame.
Thank you. So my name is Christine Golis from the Board of Higher Education from the state of Vaud. I have a question for the next generation, especially for the students. So we know that students have the worst ever schedule for their health. Have you tried at ETH to do something already? Do you have done something for the entire year, maybe to start courses after 9, for instance? And the second is, what do you do for the exams? Because we know we all pass through that. We don't sleep the night before. So we know it's the worst thing we can do for the health of our next generation. So have you done something? Have you done some research on that?
So maybe the first comment is, I think students might have bad sleep, but they definitely don't have the worst sleep, right? So there are other professions like nurses, doctors, first responders. So I mean, these people who are doing shift work, they are really having, bad sleep. So what you were referring to, I think there are two things. So the one thing is, again, the circadian aspect. Is it really for somebody who is not a morning person? Is it easy to get up 7 o'clock? I mean, at ETH, I'm teaching a lecture 7:45. So do these people, do they benefit from being there early? And the answer is no. So for them, it would be easier to just start a little bit later. And I think if we could compress time, that we do something between, 9 and 5, and only have lectures there, that would probably be good. In reality, that is not always possible. But I mean, that is point one. Your other point you raised is probably not so much related to, bad sleep is probably a symptom of elevated stress. And that is really something that is known. So right now, in high stress situation, that is probably the worst factor for sleep. So when you're in a stress state, we all know sleep is very difficult. You're lying in bed, you cannot stop thinking, you're ruminating, you're worrying, things come back, and you just cannot fall asleep. And I think there the best way is really try, and it sounds very simple, it's really some stress, self-regulation, relaxation techniques, and really also make sure in your schedule to ramp down before you go to sleep. And again, with students who are typically studying the night before, this will not happen, and I can tell everybody here, if you have kids and they are studying the night before, not a good idea. Get your sleep.
So my daughters are 12 and 14, and we live in Villars-sur-Olon, which is in the mountain, and school starts at 7:30 a.m. in the valley. So they have to take the bus at 6:50, and they wake up at 5:50. Honestly, they're doing okay, but I'm really struggling with this. Could you help me build a case where for the school we tell them it's really not good for children this age to come too early, and then you will have a happy citizen. We have 3 more questions already. Please.
Hi, I'm Yulu. I'm from Econic Partners. Thank you for sharing. It's very insightful. I have a question about wearable technologies like Oura Rings or Garmin watches. I know some people use it to keep track of their health and sleep. And I wonder, from your perspective, what will be the effectiveness of using these wearable technologies in improving sleep quality? And what are some limitations, like risk of data collections and accuracy of the information collected from the devices?
I will start with the last part. So typically these devices are measuring movement or heart rate. So some signals that are actually very far away from the brain. Let's start with that. And also, it is not so clear whether they really give you an accurate measurement of, for example, different sleep stages, because that is not so easy to extract from these measures. So when you say how accurate they are, so if you talk to sleep research, they will say, no, you cannot use that. The other question is, okay, what are we doing with that? So currently, it's really tracking sleep. And maybe that might be interesting to see when do I sleep well or when do I not sleep well. But then doing something about it is something else altogether. And I just want to say one word of warning, because sometimes these devices can have unwanted side effects. Some people become really, really, really very, very obsessed with their sleep, and they become obsessed so much that they cannot sleep anymore. And that is not a joke. So that is real. So and that of course is a little bit the downside. And you know, and again, I'm saying it once more. There is no fixed hour of sleep that you need. So you might be somebody who can do with less. So don't freak out if you don't reach your 8 hours. It might be just fine. And I think that is a little bit the problem with this technology, that currently you can measure sleep, but it's not so clear how much can you trust it and what can we do with it. But 5 years from now, that has hopefully changed.
Sir, we have a question here.
Tom Robinson, next now, Switzerland. Thank you for this lightning quick view into a topic that we all, of course, relate to in our everyday. I have sympathy for you and your daughters. As a former 19-year-old university student with horrible sleep, I know it was all self-inflicted. I'm not sure that professors can do much about that. Quickly, you mentioned a risk. You mentioned the use case of sort of placing advertisements or advertising in this super vulnerable sleep state. And it got me thinking about learning.
Yeah.
So thinking, and we know personalized learning is, you know, has come into, you know, into the world in the last 10, 15 years in a new way. Looking 5, 10, 25 years out, can you imagine or do you believe that we'll be making, rather than just avoiding the risk of some negative intervention while we're sleeping, will personalized learning and personalized sleep interventions come together?
Will you learn in your sleep? So sleep is really important for the consolidation of memories. And that is actually something we know already now. And reactivating these memories can have a better effect on recall the next day. So I would say that this is something that can already be done in labs, but very often with quite artificial tasks. So to even show this effect, right, it cannot be super complex material. So so my honest answer is I don't know whether it will ever be possible to really do that in a systematic in a systematic way, that we say you have learned something during the day and now we activate it again during the sleep, but I would definitely not exclude it. So I think it's in the cards. We have probably to test a bit more how far we can push that.
We have a question in the back, then we come here if we have time. We have 1 minute and 40 seconds remaining in the session.
Oh,
yes, so my name is Gabor Farkas. I'm a mediator and a podcaster. My question is about the impact of alcohol and THC on sleep and how the role that dreams, we haven't talked about dreams, play in a healthy sleep. Do they contribute, and how do they contribute to eliminating the things that you mentioned?
Yeah.
That's
so alcohol bad. So that's a very simple answer. You will fall asleep quickly, but you will have a very superficial sleep. And one bad thing of sleep is when you wake up a lot during the night, and that is typically when you had alcohol. To the other part of your question, dreams. So dreams are important for what we think right now. Dreams are important for memories, but they are also important, or they can be important for renormalizing some emotional content in emotional memories in particular. So yes, we are dreaming. We are probably dreaming much more than we are aware of, and it probably most likely has a function. So there's a reason why we are doing it, and for example, memories and also emotional memories might be part of that function.
Also, to answer that question, you should probably disambiguate the term alcohol, because like tequila and champagne have radically different effects. One last question, we have 20 seconds.
Okay, we'll make it short. Actually, on your first slide, you've shown that in 25 years, life expectancy will grow much faster, much more than the healthy life. And you say that we can make a lot of improvements, right, for our health with good sleep. So how come this distortion?
So that is without us doing work now. So I mean, so this is the statistics. So status quo today is probably that what we would expect to happen. So now longevity science is really coming into it, and I think it's coming more and more to the forefront. What we still have to learn is whether we can really reduce the gap. We don't know that yet, but I think with a lot of knowledge and technology coming out of the lab, that is now in the cards, and I think the mission for science is whether we can actually change this trajectory.
Interestingly, maybe it's about time also that societies start measuring more using like well-being rather than the full life extension. You know, you make the difference between the good health age and the lifespan, and maybe the good health should be have more weight in the public debate, because it's a measure that we don't hear. We hear about the lifespan, but we don't really hear about lifespan in good health. Maybe that would be a good addition to the public debate. We are finishing 1 minute behind schedule, which is amazing. Please give a warm round of applause to Nici Wenderoth. Thank you.